Good Thursday to you, everybody, in Com 702. Welcome to week, boom, bam, bam, only one finger, 11, not week 16, 11. How's everybody doing? Huh? How you hanging in there? On the other side of spring break, modular week, whatever you want to call it. Excuse me just a second. What do we have here? Oh, Great Smoky Mountains. Fantastic region. I don't live too far away, but I've only visited it one time thus far. But I had, the rain notwithstanding, I had a great hike. Looking forward to going back. So things to look forward to as the semester moves along, and you are getting close to the end now in week 11. But there's still some important work to do. So before we get to the readings from last week, week 10, and some of your answers, a couple of quick housekeeping items for your papers. Now, over modular week, I don't say spring break, but you know what I mean. You were asked to use the discussion posts for week 9. Post up your topic, read those of other classmates, and then, exchange comments and suggestions. I had a look through them. Okay. You should be somewhere real close, at this point in what you're doing to, if you're not actually gathering data yet, you should be very, very close. Why? Well, it's what now? March 22nd. These are due by April, 21st is the due date for the paper. I'm sorry, 23rd. So, a month and a day. And one of the things that you want to plan for, give time for, when you're doing quantitative analysis is data gathering. Because unless, say, you're doing, content analysis, which is really, in my opinion, not the best fit for quantitative analysis, I'm sure other people might look at it differently. You want to give yourself a little extra flex and time because you don't know who is and is not going to take your survey. I mean, unless you can corral them all up and sit them down in a room and say, here, take this survey. If you're throwing it out on various survey instruments, SurveyMonkey and Babelfish or Google surveys, make sure whatever software that you throw it out on does a couple of things for you. One, lets you export the data in a CVS or Excel format. And then number 2, and this is really important, when you enter a question, like say, SurveyMonkey is fine with this, but Google Docs, some people use Google Docs. When you enter a question, make sure that when someone responds to the question, it produces a numerical response. It registers a number on the other side. Because if you run a bunch of surveys and, say, you ask about sex, male or female, and you want to assign the number 1 for male and the number 2 for female, and somebody says male, and on the other side, it doesn't report number 1, it reports male, and then gives you a pie chart, which is often what you get from a Google form, saying, oh, you have this percentage of females and this percentage of males answer your survey. All right, well, that's terribly interesting, but that is worthless to you when it comes to SPSS. Now, what you could do if you're a crazy masochist is once you got the number on the other side, say through Google Docs, of say how many males or how many females answered your survey, or if you're using a Likert scale, how many people selected, strongly disagree or strongly agree or agree or disagree, whatever. And a 5-point Likert scale is fine. If you wanted then to go into the report produced by Google Forms, and every time you saw a strongly disagree, you would enter a number 1, and then strongly agree, you'd enter a number 5. Want to disagree, you'd enter, you'd enter a number 2, and then agree, you'd enter a number 4, and right smack in the middle, the meh, you'd enter a number 3. Okay, so if you wanted to go and encode it by hand, knock yourself out. Better you than me. Don't do that. Make sure that you give yourself time to figure out your survey instrument and that you give your survey instrument time to circulate out there to get the data. So you might be thinking, oh, well, a month, I got a lot of time. Don't take a chance, okay? Because that's something that you can't control, again, unless you have the capacity to sit everybody down in a room and say, now we're going to be taking a survey, and thank you very much for taking the survey. You have to wait and wonder who's going to take the survey, okay? So give yourself a little bit of breathing room. All right. Also, as you're looking towards the end of the semester, and I mean, I'm looking forward to this. Remember that we have a final exam on April 29th. How do I prepare, you might be saying? Well, make sure that you have gone through and you understand, and we're going to talk about this a little bit today. You understand the questions that you're getting in Blackboard. Excuse me, that's the last of it. Now, I can see from a number of your answers that you're Googling the questions in Blackboard and you're posting, yeah, correct. The responses that you're coming up with are correct, but that's not the important bit. The important bit is that you understand it, okay? Because when it comes time for the final exam, there shall be no Googling of anything. So make sure that you go back, you read the Blackboard discussion post, you understand the concepts. And I know there's been a lot thrown out this semester to wrap your head around, and a lot of terms and new concepts to remember. Flashcards work wonders for this sort of thing. And excuse me. And it's like, okay, starting with just very, very simple. What's the difference between mean and medium? Or what in the world is a Cronbach alpha? Because again, as we've mentioned a number of times, this is not unlike learning a different language. Why agua for water? Well, just because. I mean, I could break down, give you the etymological origins of the word, but that's not the point. You're not here for etymology. All right, you're here to understand the concepts of quantitative research. So instead of wondering, well, exactly, well, Likert, why like all that, or Pearson's, it's just memorize it and then understand what it means. All right, and that will put you in good shape going into the final exam, because the area where I have found, I've been doing this class now for a number of years, that people really stumble along is the final exam, and you don't want that. You don't want to get clear to the back end of the semester. You take a final exam, and it's worth 20% of your grade, and you're looking at it and you're going, huh, what? That's not you. Okay, let's take a break. Let's take a look backwards to last week, week 10. I'm not going to review your posting of paper topics. We're going to get right back into the stuff. So this last week, week 10, okay, we were looking at data reduction methods. First and foremost, what in the world is that, and why in the world would you do that? Okay, I will, just for yucks, I'm going to include a link in the announcement for this video to my dissertation, because I spent a lot of time with data reduction. We became very, very good friends, fast friends, when I did my dissertation. And, this is an extremely useful tool, especially when you have multiple variables that you're trying to determine what sort of impact do they have on the outcome. So you have multiple independent variables, and you're trying to determine what kind of impact they have on the dependent variable. And it may not be either practical or useful to consider each of those independent variables separately, each with an ANOVA or a t-test, or regression analysis, if you're trying to find out how much of dependent variable this is being caused by this, so a regression analysis. Because maybe in terms of the categories that these independent variables go into, the category is common across all of them, but they're different things. Let me give you, I know I'm sort of circling the drain here. Let me give you a real life example. And this is, I'll post this link in the announcement. Okay, so in my PhD, a mixed method, a quantitative project that I did. I was very interested in how people in really distressed situations used social media. And at that time, I was working in Iraq, northwestern Iraq, and in Syria during the war with the Islamic State. And I was spending a lot of time in and out of refugee camps for the people who had fled the war. And one of the things that I noticed as I traveled and worked there is that people, in trying to escape the onslaught of the ISIS armies, they would flee from their homes, they would flee from their villages, and they would forget, as you would, because you're panicked, all kinds of stuff. They would forget their money, they would forget their identity papers, which in Iraq, which is a really statist state. Running out of the house without your identity papers is like running out of the house without your pants. It's just not done. But they would forget their identity papers, children's birth certificates, all of these things that you need if you run. You may not know that you need them. And now you're going to be processed en masse by an organization like the UN that's going to decide what kind of camp you go into. Not good. But the one thing consistent across, gender and age and geographical location, almost, it was hard for me to find an exception. They took their devices to connect to the internet. They took their smartphones. They took their tablets. They took their laptops. They may have forgotten all their money, but they've got their laptop. I thought, well, that's very, very interesting. I'm assuming if you have a phone, you have a laptop, you have a tablet, you have it for a something. Are you calling? You're calling people on it, and are you using it to connect to social media? And if you are using it to connect to social media, what type of social media are you connecting to? So I made up a questionnaire, a survey instrument, and sent it out. And I asked them, do you connect to the internet? Yes, no. When you connect to the internet, do you connect to social media? Yes, no. Among the following social medias, which ones do you use? And I listed a whole bunch of them. I even counted some that people might go, is that really social media? Like Skype, MySpace, how old is that? Twitter, LinkedIn, Pinterest, Tumblr, no Grindr and no Tinder. Sorry, kids, as Uncle Roger would say. Yahoo, Google, Viber, WhatsApp, Instagram. I don't think TikTok was around back then, so I didn't include that. Okay, so all of them are social media. Yeah, all right. But they're distinct because you might have a WhatsApp account, but you may not have a Skype account. Or you may have an Instagram account, but you may not have a Viber account. But they're all social media. So by way of social media, people were using all of them, some of them, most of one or two of them, and none of the others. And I wanted to find out what they were using them for, the social media. One of the questions that I wanted to get at was, did they use social media as a means by which to get out of the camp and to get to somewhere better? So that was the dependent variable. Okay. Did they use it? Did they use social media as a means to get out of the camp? This is how they or I also asked, did they use it as a means to let the world know what was happening to them? All right. So when I started looking at the social media use, that many of them had used all of the various social medias, but to, a certain degree here, a certain small, I use Instagram, and I really don't use Pinterest, and I use Viber, but I don't really use Telegram. Okay. So I had all of these independent variables, different types of social media, but they were all social media. So I had to bring them together into categories. I had to, reduce down or factor down the variables, because although I had asked about each one individually, they were all of the same category. Bring them down into one new variable, independent variable, to see what kind of effect it had on the dependent variable, that is, used as a means to get out of the camp or to let the world know. Okay, that's what you're doing when you're doing data reduction. You're not reducing the data in a category. You're reducing the number of categories down to a different category of data that then you can use to run an equation, run a regression analysis, run an ANOVA, run a t-test, whatever floats your boat. Okay. So that's what we're driving at, or we were, last week. Okay, let's take a question number 1. Among the various data reduction methods, what is factor analysis, and what is the difference between principal component analysis and exploratory factor analysis and confirmatory factor analysis? All right, so let's see. Who do we have here? Alan. Let's take you, because I think you went first on this. Okay. All right. Alan, factor analysis is a statistical method used to identify underlying hidden variables and explain the variance in a set of observed variables. Okay. Now, see, again, you're taking this right from field, which is good, but make sure, and I'm not talking to you necessarily, Alan, but make sure that you understand what that means. This data reduction technique allows researchers to identify the essential variables in a data set and reduce the number of variables needed to describe the event occurrence, like, say, all of these different types of social media, Telegram, Viber, Pinterest, Skype, YouTube, because you can communicate with people, by way of the comments, to reduce them to a single variable. And, I actually came up with a number of single variables. Like I came up with like social media category 1, social media category 2, social media used to get money, social media used to get help, social media used to explore the internet, stuff like that. Okay. Okay. Principal component analysis, back to you, Alan. Principal component analysis is a technique used to transform a set of correlated variables into the smallest set of into a smaller set. There you go. You got it right. I read it wrong. Of uncorrelated variables known as principal components. And this is again from field. A PCA, principal component analysis. All right, that's short. Aims to reduce the number of variables while keeping the most variability in the data. Okay, that's pretty straightforward. Do you understand that? Now, if you don't, feel free to email me or call me. Even better, call me during an office hour and I'll walk you through it. Okay. Exploratory factor analysis identifies the underlying structure of a set of observed variables. However, unlike PCA, EFA is a model-based approach that allows testers to test and refine hypotheses about data structure. EFA can be used when there is no clear theoretical framework for underlying structure of data. Now, for me, that was not a problem because theoretically, I could say all of these things, Telegram, Viber, Skype, are social media. And so there was I sort of designed it that way when I put the questionnaire together. There was a natural connection between them. Okay. And then finally, confirmatory factor analysis, CFA, is a statistical method used to test the fit of hypothesized factor structure to data. CFA is a model-based approach that requires the researcher to specify an a priori hypothesis. Remember, a priori, on the face or, sort of right up front beforehand. Hypothesis about the structure of the data. CFA can be used to test whether data support a hypothesized factor structure. Okay, good answer. Does everybody understand that? And if you don't, again, please, get in touch with Dr. Brown or I. Okay, question number 2. How do you decide? Geez, what is wrong with me? And I'm out. I didn't even have coffee. I had tea. That's probably the problem right there. But it is Earl Grey, so there's a bit of caffeine in there. Okay, how do you decide which kind of factor rotation method to use when conducting a factor analysis? And that's the term, by the way, when you're reducing these down to a new factor. It's called factor rotation. Why is it called factor rotation? I'm not exactly sure. Somebody tell me. I don't remember. Okay, Larissa, you smashed it on this one. Let's take a look at you. Andy Field suggests that deciding which type of factor rotation method to use in a factor analysis depends on researchers' theoretical and practical goals and the nature of the data being analyzed. Woohoo, very good, very good. Okay. Orthogonal, all right, rotation methods are helpful when the researcher is interested in identifying distinct non-overlapping factors that can be easily interpreted. Okay, now you find these terms when you're setting up the factor analysis in SPSS. All right, so you're not going to have to guess. What does it mean? You'll select that by way of process. On the other hand, oblique rotation, which is what I used, methods are helpful when the researcher believes the factors are likely to be correlated in real life, because they were correlated in real life. In the minds of the users, they were all social media. And that was the connection between them. These methods are appropriate when the goal is to identify factors that are related to each other and to examine the complex relationship between them. Okay, good answer. Question number 3, what are the general guidelines for determining which variables are loading strong enough on a factor to keep that variable in the measurement scale? Now, I'm going to read, who do we have here? Shonda, excuse me. The good answer. Let me read your answer and then I'll get back to what I was going to say. According to Contributor, I'm not sure, is that an online site? Once you run a factor analysis and think you have some usable results, they might. I guess you could not have any because none of them are showing up strong enough. It's time to eliminate variables that are not strong enough. Okay, they usually have low factor loading, although additional criteria should be considered before taking out a variable. As a rule of thumb, your variable should have a rotation factor loading of at least 0.4 onto one of the factors to be considered necessary. Some researchers use more stringent criteria, such as a cutoff of 0.7. Okay, and this is Ron. For example, when the highest loading a researcher finds in her analysis is 0.5, this helped me to understand the factor loading concept better. Okay, that's good. Does everybody understand that? Okay, because for instance, you've got all these different factors. And so I asked about social media, and I had MySpace on there. Okay, how old is that? So although some people were selecting MySpace, it really didn't come through that strongly. So maybe it gets, I think I had something like 18 or 19. Did I have Friendster on there? I don't think that exists anymore. Anyway, types of social media, and the ones that are just not showing up as a variable, meaning a factor, meaning that people are using them in any significant numbers, chuck them out. Okay, Alan. Let's see. I was going to look at your answer as well here on that. I know that we read you last time, but I liked what you have to say. Where'd it go? Okay. I'm sorry. It was Amanda. Okay. Amanda, when looking at the general guideline, I find that there are many things that a researcher can do to determine which variable are loading strong enough on a factor to keep the variable on the measurement scale. According to Mixa and Elpis, I hope I pronounced those names right. There are a few things you should look out for in determining the variable. Data collected could be an adequate sample size. Internal data are assumed. No outliers exist. Okay, so did actually anybody use this stuff? And then like for maybe MySpace, all right, I think I surveyed like 350 people or something. Let's say the 350 that 249 didn't use it, and there was one person in there that used it all day, every day of the month. MySpace. Okay, that would be an outlier because that would cause a weird spike in the numbers of people using MySpace that would come out in the total data. Okay. All right. Also, one should remember that factor analysis is based on linearity assumptions. If one uses nonlinear variables, it will change the linear variable process. Good point. There are other things researchers can do when loading into SPSS, such as look for variables loading at least 0.4 or higher on the desired factor. Consider variables that have a strong loading of at least 0.3 on the desired factor, but also look at the loading of that variable on other factors to make sure it's not loading strongly on other factors. Consider variables that are loading firmly on a desired factor, but also moderately on others. And if you go to, what page was it? Like page 54 in my dissertation, I'll explain to you how I grouped the various factors into new into categories to create new factors based on how they loaded, all right, against each other. And then let's see, number 4, consider variables loading at least 0.2 on the desired factor. However, see if it also loading on other factors to ensure it is not diluted by loading multiple factors. Okay, good answers, the both of you. Does everybody understand that? Okay. All right, let's take a look at question number 4, which really gets to the meat of it. Okay, so that you're going to use oblique rotation because, okay, there's a natural association between them. You run a factor analysis. You get you get a loading number. It's 0.4 or above. You go, okay, great. These guys all go together. How do you determine which ones they're presenting strongly enough or significantly enough as a variable that they're worth your time considering grouping into this new factor? What do you do? Question number 4 gets at that question. Yes, we get very excited about quantitative research here. How do you create measurement scales for the results of factor analysis, and what are the general guidelines that you should follow when testing the reliability of a measurement scale that is composite variable? Amanda, good answer here. Let's go to you. Creating measurement scales for factor analysis results. When creating measurement scales for the results of the factor analysis, one should identify the variables that are loading onto each factor, then determine the range of each of the variables associated with each factor. Okay, yeah, because that's sort of like what we're doing up in question number 3. Once the range of the variable is determined, one should create a measurement scale by assigning a numerical score to each of the variables based on the range. The score should be a numerical representation of the degree in which the variable is associated in the factor. Okay, that's true, but we're going to here we go. Your second item. So I would encourage you to do this second thing first, and then the first thing second. Okay, testing of the reliability of a measurement scale composite variable. When testing the reliability of a measurement scale, one should first assess its internal consistency by calculating Cronbach's alpha. Aha! So when you do this, you'll see there'll be a Cronbach's alpha score for the various variables, okay, that you're putting in there. And when you put them together, you'll see, if you group them together, you'll see a composite score, okay? This idea measures the correlation between different items in the scale and should be higher than 0.7 to be considered reliable. Now, it may take you, let's say that you had variables, again, from social media, all right? And it may take you a little bit to sort of group them together and move them around to go, oh, okay, that's a Cronbach alpha of 0.7 and above. Now, if you look at, again, I'll switch the link and go over to page 54. If you look at what I did, I actually allowed new factors, new variables through. Specifically, social media is used to help, and social media is used to connect to the internet, that had scores lower than 0.7, but not by much. I think 0.68 and 0.66. Okay, so it's not do or die at 0.7. Right, but back to you, Amanda. Additionally, one should assess the scale's construction, I think you mean, validity by comparing it to other scales that measure the same concept. Finally, one should also consider the retest reliability of scale by assessing the degree to which the results remain consistent over multiple scale administrations. Okay. All right, that's a good answer. Good answer. Okay, does everybody understand that? Again, this is, we're getting further down into murkier waters, but factor analysis and factor data reduction is extremely useful, especially if you want to start getting at the wheres and wherefores of a phenomenon with a finer tooth comb. And it's not a matter, let's make sure that we keep the horse in front of the cart in what we're doing. All right. It's not because, you know, this test in quantitative methodology is better than that test, right? It's not because, say, you know, factor analysis and you know, running a number of variables through factor analysis and using an oblique rotation and looking for a certain Cronbach alpha number that groups them together, and then you create a new variable, a new factor. It's not that that's better than, say, a straight ANOVA or a t-test. Okay, no, it's because in life, in real life events, it's rare, all right, that there's a single factor, a single variable that drives the outcome. Now, we can test for single variables, you know, like, say, think way back to lab number 1. Was it 1, 2? When we were looking at the t-test. We can compare the means, the average of men and women that you know, use social media, and then their faith is strengthened. All right. But in real life, is it just using social media or watching videos? You know, I have to be honest, I can't remember exactly what the question was right off the top of my head. Is it using social media or watching videos that was the thing that strengthened their faith? Maybe they were doing it with friends. Maybe they were doing it as part of a youth group in church, and when they, you know, when they watched them, that's where they were. So they were in an environment that naturally led to the strengthening of their faith. Did we ask them those questions in the survey instrument? So be careful when you construct your survey instruments, because you can wall off, you can block out, you can make invisible really important forces that are shaping the behavior that you're trying to study, trying to determine. So, you know, in this case, in lab 1, strengthening of their faith. And so you can conduct these single analyses, but remember, just because you can run it through SPSS and you can get a high R value, you know, a high Pearson's value, you know, let's say it's crazier high than 5%, you know, it's way up there. It's like 20%. Okay. That doesn't mean that there aren't other forces at work. And you know, we have to be careful because we can oversimplify the causality in human behavior. You know, you can look at, I mean, it's easy to play games with this sort of thing. I think I've used this example before, but, you know, bear with me, I'll use it again. So you could count the number of ice cream cones sold in each month throughout the year. Now, if you haven't heard this one before, all right, you know, you might be asking me, why would I count ice cream cones? Play along with me. You could count the number of ice cream cones purchased throughout in each month throughout the year. And then you could count the number of drownings in public pools. I know, horrible thought. Within a city each month throughout the year. And, you know, wisely recognizing that in December, January, February, March, the pool is actually closed. Okay. And then you could run a correlation analysis, a data analysis in SPSS, in which you looked at the rise in the sale of ice cream cones and the rise in the number of people that drowned in public pools. And you could go, aha, ice cream cones are drowning people. All right. Well, just because there's correlation doesn't mean there's causation. Okay. And just because you can plunk numbers into SPSS and get an R value out the other side, you go, whoa, look at that, doesn't mean that the one thing is causing the other. So be careful. Be careful with what you plunk in and then make assumptions about what's driving the phenomenon. And as you write your papers, it's okay for you to, you know, this is probably one of the areas where it's okay, most okay for you to use sort of hedgy, I'm not sure-y type language. You can say there's a correlation, but it's weak. So this suggests, but we can't be sure, et cetera, et cetera. That's not only okay, that's good. because that's honest as a researcher. Okay. All right, everybody. I can see we're running out of time here. Again, if you have questions about this, reach out, get in touch. Otherwise, have a great rest of the week. I'm praying for you. As always, thinking about you. And I'll see you on Blackboard. Okay. Bye bye.